Morning. My goal today, I set a goal for myself today to record all of my lectures. So far, I only got one out of three. Okay. Now, you wouldn't have to use this include file that we've been using, but it's certainly convenient. If you didn't, you'd have to find out the addresses of all of these control registers and then hardwire those into your program. Does anyone know how to increase the font size? So actually, it doesn't seem to respond to my mouse control wheel. Do I have to actually go into the settings somewhere? Can you see that? No. Okay. Sorry. I'll look on how to do that. It's probably one of the. If I look for the definition of P1, first I see P1 is just a define, and it's defined to be this god-awful long name, DIO port odd interruptible type. And this is an address. It's DIO base plus 0. And then notice the even interruptible type for P2 actually is at this exact same address. So we'll see how that's laid out. But P1 is an odd interruptible type, and P2 is an even interruptible type. Okay. These are actually structs. So P1 and P2 are both pointers to structs. And then so now we can find, at these, so P1 is defined to be that address. And it's further defined to be a pointer to a struct at that address. So now let me see if I can find this. Okay, here we go. Now right below this is the even interruptible type. And notice how this is defined. One thing they've done is define this to be a type def, but here's the underlying struct. The I and the IO, just ignore that. Those are all defined to be the volatile keyword. Okay, but let's just forget about that. Notice the first element in this struct is a uint8 T type, so a byte, that's N. So P1, which is a pointer to this type, P1 with that arrow notation N is going to point to this particular hardware address register, which is the first register in the struct, so it would be at that DIO base. So it would be at this location. And then this is just saying, well, ignore the next byte, which is part of P2. If you'll notice how the even one is laid out, they're saying ignore the first byte, and then N is in the second byte. But remember, these are alternating. So the reserved 0 here actually is P2N. Okay. You could use P1N reserved D0 actually as P2N. Okay. So they just did some trickery. They're skipping here all the P2 control registers in this odd port type. And similarly, they skip all the P1 registers in even type. So really the way this thing is laid out is P1 in, P2 in, P1 out, P2 out. And they're just skipping this so that when I use this P1 type, I get access to these individual, and they're all here, N 3 bytes later is out. 3 bytes after that, I'm sorry, 2 bytes, 0, 1, 2. 2 bytes after that is the direction register. Then the resistor enable, then the direction string, and our selection registers. We haven't used these others yet. Okay. And then we have a similar layout for the even ports. Okay. Does that make sense? Yes, no, clear as mud, kind of. But our P1 is really, when we're using P1 and P2, those are just addresses. And they're addresses of the first element in these structs, or pointers to these structs. And then P1 arrow selection 0 actually becomes the corresponding 8 bits plus the offset address. And then we can set read and write to those particular registers. All right, I think that's all I've got today. I'll collect those little, if you got your questions written down, I'll collect those. If you didn't put anything down, that's fine. They can be anonymous. You guys have questions? You didn't have to put anything down. Did you have one? Nope. All right. See most of you in a couple hours. I'm going to be locking my door because I've got to write a test that I have to give in an hour and a half, 2 hours. So don't bother me because I won't be opening my door. See if Jeff has one. I can give you one. Okay. See if Jeff has one. Okay.
Oh, yeah. Yeah, no.
Right. When I set up the problem, I said, this is the data I wanted you to use. But the actual array that you define, and that problem, if I'm remembering it correctly, it said this array is supposed to have the length of the array as the first element, or the number of data elements. So, with 5 elements here, 5 as the first element. And if it's a 3, then I would just do 3. So there are a couple of different ways to keep track of the length of the array. One is with a separate variable. One is actually using a special terminator. Another is to always include as the first element of the array the length of the array. That really only works for int type arrays, though. But, or, in that case, I think it was int, uint. Yeah, int, at, so assigned int type. But, so when you define the array, make sure you put the number of elements in the first. Yeah, so when you write your function, you have to skip over this because it's not a data value, but it tells you the number of data values that are in your array. Let me see. It's not on the website. I'm not going to put it there. Okay. But let me check. Okay.
I think I'm studying this place.
Okay. Yeah. It's on the website.
Thank you so much.
funding.